All right. Teams froze on me, so you probably figured that out. 6.2 is going to be in two pieces. All right, so we were talking about classifying quadrilaterals here. So a rectangle, so by the way, quadrilateral, 4 sides, right? That's what we're talking about, a 4-side polygon. A rectangle has 4 right interior angles that measure as right angles. With 2 pairs of parallel sides. As a picture, of course, easier to show as a picture. There it is. I'll just put a little right angle there. Right angle. Square has 4 right angles with 2 pairs of parallel sides. What else can we say? And all side lengths equal. Okay. So up here, if I denote this, these side lengths on the rectangle as L for length and W for width, then over here, then I could just call this L for length, and this side would be the same, L for that length, right, for a square, We say that the area formula for a rectangle or a square is just the product of those 2 dimensions. So A is equal to L times W for a rectangle. A is equal to L times L for a square, or whatever you like to call the sides. So the book calls them S for side, I guess, but it doesn't matter what you call it. The point is you're multiplying it by itself, and if you're multiplying it by itself, you can write it as that side length squared, L squared. So that's why we call that a square. Like up here, that exponent of 2, that's why it gets its name as square, like L squared, because it literally is the area of a square with side lengths L. A parallelogram has 2 pairs of parallel sides. But we don't say anything about the sides. Oops. It's 2 pairs. Sorry, we don't say anything about the angles. A parallelogram has 2 pairs of parallel sides. So not necessarily with right angles, like a rectangle or a square. So maybe a generic parallelogram would look like this. So those 2 parallel sides, top and bottom, and then left and right should be parallel as well. So it's like a tilted rectangle. And we say that the parallelogram, we talk about its height. Its height is h. And we tend to call the base length, instead of calling it a length or a width, we call it b for base. And the area formula is going to be, for a parallelogram, base times height. Okay. So these are all just the same thing, right? You're just taking the product of 2 numbers. Right, I guess I could put L dot W for times, but you know, if they're squished together, that means you're multiplying the 2 numbers together. So I'm not multiplying that slanted line. So that height is an interior measure on the parallelogram. Now let's talk about trapezoids. Still a 4-sided shape. Oops, trapezoids have exactly 1 pair of parallel sides. one pair of parallel sides. So maybe top and bottom are parallel, but the outer two sides, the left and right sides, are not parallel. So this might be a trapezoid there. And we like to denote the trapezoid's height. And also we like to denote those two parallel sides, which in this case I'll call base 1 and base 2. We like to denote those two, base 1 and base 2. And our formula for area is going to be very similar to parallelogram. It's just that instead of just taking base 1 times h or base 2 times h, we're going to take the average of those two bases. So how do you find the average of two numbers? How do you find the average of two numbers? You add them up and divide by 2, right? That's the average of the bases, and then times h. So it's really the same as parallelogram, base times height, except if we've got two different bases, we need to find the average of the bases before we multiply times the height. We're going to run some examples with all of these. Let me make a note here about perimeter for these shapes. Perimeter will be the sum of all exterior sides. Okay, so no need for formulas there. Just add up all the sides on the outside. Triangle real quick. Sorry, I kind of going out of order. That Teams freezing up on me kind of threw me out of order here. Triangles, I meant to do this earlier. Let's see, triangle area. If you have some triangle like this, just some generic triangle, we like to denote its height and its base, and its area is going to be, again, very similar to a parallelogram, but it's 1/2 base times height. So it's just like a parallelogram area, except it's half of that, which makes sense if you think about it. A triangle is really just half of a parallelogram. Like if I copied this and flipped it over and put it here, it would be some wacky looking parallelogram. So for its area, I just take half of base times height. I could also, just so you know, it could have a weird triangle oriented like this, where its base could be here and its height might be drawn all the way out here. The point is the height is going to be the distance from that base, from base all the way to the tip of the triangle. That vertical distance from the base, to the tip of the triangle, the highest point of the triangle. Okay, now let's do some problems. Oh, by the way, what is area? Area is just how much, I've kind of assumed you know what area is, but real quick, I'll just write it down. The area of a polygon it's just the amount of square units, the number of square units needed to cover the polygon. And when I say square units, I mean like, for example, let's run, what is this, example 3? That's example 3 in the text. I'm going to call it example 2 here. Okay, so let's find each area and assume the grid lines are 1 feet apart, so that'll make sense when I draw this. Let me see what's going to be the best color to use here. I think I'll keep using, yeah, purple. Okay, gonna have a grid here. Let me do some counting. Okay. Okay, how big is this rectangle? Okay, you could probably skip through me drawing all this. Almost done. Okay, so I've got this grid. This is example 3 in the text if you'd like to look at a prettier picture. And I've got a rectangle on here. A rectangle. Let me draw this marker, hang on. Okay, got a rectangle that is 4 units tall by 8 units wide. 4 units tall by 8 units wide. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And I want to find the area of this. So I know by my formula that A should be equal to length times width for a rectangle, which in this case is going to be 8 times 4, which is 32. But these are each 1 foot apart, so I'm going to say 32 feet squared. So that's what I mean when I say square units. The area of a polygon is the number of square units. There's the square units coming in, right? So if I'm measuring length of something, like how long something is, I'm using like feet, for example. But if I want to measure area, now I'm moving into 2 dimensions, right? So I'm measuring in square units, like feet squared, or maybe centimeters squared, or meters squared, something like that, inches squared. And what is this 32 representing? It's representing the number of little blocks in here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 32 little grids, little grid box. Okay, what about, I'm going to skip part B. If you're following along in the text, there's a part B, but I'll leave just as extra practice if you'd like to go look at it. But I am going to do part C, which is a triangle. So here I go again. I'm going to draw another grid thing. It's hard to draw under this camera here. That's why my picture looks all crazy. Okay. 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, and now I'm going to draw a triangle on here, and we're going to find its area. Okay, it's going to have a base of 8, 1, 2, 3, 4, 1, 2, 3, 4, and a height of 5. 1, 2, 3, 4, 5, and then I'm going to connect these. Ooh, my eyes are going cross because of these lines. There we go. So it's 8 across. Its base is 8, So recall the area for a triangle is 1/2 base times height. So I'm going to have 1/2 base is 8 units long, 8 feet long, right? If each of these squares is supposed to represent a foot, and 5 units high. Oh, just in case no one, I know we have some international students in our class. A foot is an American measurement that is rough. It's 12 inches. That probably wouldn't mean anything to you either. It's like roughly like this long. It's like a piece of paper is almost a foot. Like a little bit longer would be a foot, just so you know. All right. So obviously these little squares are not actually a foot. They're just supposed to represent, each one is supposed to represent a foot just for the sake of argument. Okay, so here, how would I multiply this to find the area? Here I would take half of this, right? Or I could take, there's many different ways I could go about this, but 8 times 5 is 40, and half of 40 is 20, and I'm measuring feet squared. So apparently, now if I color this in, it's not going to be totally clear that it's 20 feet squared. But let's see, if I get the full blocks, there's 1, 2, 3, 4, 5, 6. This one's full. 7. I guess this one's full too. 8, 9, 10, 11, 12, 13, 14. 14. And now these are like pieces, right? So somehow between the rest of these little pieces, this piece here, and these pieces, we end up with a total of 20. It's not quite as easy to see when the shape is not like a rectangle or a square. That's why we tend to just rely on the formulas. Now also something to keep in mind is the length of this slanted line did not come into play with finding area, right? It was all about the straight, the horizontal and the vertical dimensions or measurements. The slant line would come into play if I wanted you to find perimeter, right? But I didn't ask for that here. All right, now getting to the point where I'm going to just start running a bunch of examples. We'll get to circles at the end. I'm going to do a problem involving area of a compound quadrilateral shape. We're going to do a parallelogram. We're going to do another triangle, and we're going to do a trapezoid, and then we'll get to circles at the end. Here's a shape that we have. So this is like a floor plan. Let's say a floor plan for some floor that you're trying to paint. I don't know why you would be painting the floor. Maybe that's a bit weird, but at least all the shape is built from like right angles and everything. So this is technically a 1, 2, 3, 4, 5. It's a hexagon, but it's a crazy looking hexagon, but we're not worried about like interior angle measures and all that. We're worried about finding the area, and I'll make that clear in a moment. So these are measurements that we have, and let's say part A, let's say find the area. In part B, here's a good question. If a gallon of paint can cover, so if you've ever like bought paint, you know, it'll tell you how much is in there by square footage. So let's say a gallon of paint can cover 350 feet squared. How many gallons are needed? How many gallons will you need to buy if you're going to paint this floor? So how do we do this problem? Because this is like a real world problem, right? How do we do this? Well, first we need the area. How do we find the area? Well, we got to decompose this thing into 2 rectangles. We could either cut it right here and then find the 2 areas and add them up, or we could cut it right here and find the 2 areas and add them. I'll be right back. 1 second. Okay, so let's say I decide to cut it right down vertically like this. Now I'm going to have two new rectangles, and I better redraw them and get the measurements right. So this left-hand one has as its, well, I need to be careful here. So it's definitely a rectangle. All its angle measures are 90 degrees inside and all that. This side will be, what will it be? 7 plus the 9, right? 7 plus this side, which is 9. So that's 16 feet. Okay. 7 plus 9, because this is 9 right here, from there. This side down here, well, all the way across is 40, but from here to here is 28 from right here, right? So what must this piece be? It must be 12. Cool, so now I can find the area of this. Area of this is going to be 16 times 12. Area is 16 times 12. So just pop that into the calculator. 16 times 12, and we get 192 square feet. So I'll say FT squared. That's square feet right there. Feet squared. 192 feet squared. That's this one. Now what about the rectangle on the right? This one's a bit easier to look at, or rather to measure. We already have the measurements. That's 9 feet. This is 28 feet, right? So it's a bit harder to build these measurements and to pull them from, putting together the numbers in the picture. Now, in the real world, you would probably just remeasure, right? But maybe for some reason you can't measure from here to here, or you can't measure, this side or this side for whatever reason. All right, so this area would be 28 times 9, of course, just product of the two sides there, and that's going to be 252 feet squared. So my total area, which I'll denote with green up here, I'll say A sub T for total, so that's A subscript T, is just going to be the sum of these two. 192 plus 252, which is going to equal 444 feet squared. That's the total area. For part A, that's the answer, total area. Adding up this rectangle plus this rectangle. So this whole shape, this original whole shape, has a square footage of 444 square feet. So if 1 gallon can cover 350 feet squared, how many gallons will you need? Well, you can just do, more than one, right? Now, you would probably just buy 2, but let's see exactly how much you would need. Let me cover this up. So we would say 444 feet squared divided by 350 feet squared this is going to be gallons, is going to equal, and then, well, approximately, if I round to the 100th place, 1.27 gallons. So if the store sells like half gallons, you could save a bit of money by just buying 1 whole gallon and then a half gallon instead of buying 2 whole gallons. So at this point, this is when you have to make a decision as the consumer, the person actually trying to do this, like whether maybe you have other stuff to paint, so maybe you should go ahead and get 2 gallons, Okay. As an extra bonus problem here, let's do, what is the perimeter of the shape? And what did I call this before? I called it a compound shape. It's a compound shape because it's built from like simpler shapes, 2 rectangles. All right, anyways, what is the perimeter? Well, I would have to know the side, all of these sides, right? But I do, right? all the exterior sides. I know that this exterior side over here is 16. Remember, I found that earlier, 16. All the way across. I'm talking about from bottom to top, right? That's the 9 plus the 7. That's 16. Oh, feet. And also I know the top length is 12 feet. Okay, why am I writing these down? Well, because if I want the perimeter, I need to add up all of the sides outside. So I'm going to say, starting from here and going clockwise, 16 plus 12, don't forget that little 7 there, plus 28 feet, plus 9 feet, plus 40 feet. And that 40 feet is accounting all the way across there. And what does that give me? Well, calculator can tell me 16 plus 12 plus 7 plus 28 plus 9 plus 40. P for perimeter, 112 feet, not feet squared, right? Just feet, because perimeter is a measurement of length. Why would you ever need perimeter? Well, oh, hang on, let me see, I'm getting off the page a little bit. Why would you ever need perimeter for this shape? Well, maybe, I don't know, maybe you need to paint the edges. No, not paint, that's a bad example. Maybe you need to buy trim for this floor all the way around. You got to buy some trim and you need to know how much trim you need. Trim is the little wood piece that goes around the bottom of a wall, in case you don't know, or the around the edges of the floor at the where the floor meets the wall. So maybe you need some trim. How much trim do you need for a floor plan like this? 112 feet. Sorry, I was just reading the example. Find the area of the parallelogram. I'm going to say find the area and perimeter. Why not? And I got to draw it for you. So here's the parallelogram. There we go. I've also got to tell you how long this side is. I'll say that that's 8 meters. All right, here we go. Area for a parallelogram is base times height. My job is to say which numbers are the base and the height. Clearly 13 is the base, right? It's on that horizontal side, that's the base number. Which number is the height? Is it the slant line or this vertical line? It's the vertical line. Oops, sorry, I don't want to write units, so I'm just going to say 13 times, and then the height is 6. 13 times 6. So I'm getting 98 meters squared, square meters. The units are meters, so if you multiply them, you get meters squared. That's not right. It's not 98, is it? 78. Sorry, going crazy. 78. 78 meters squared. What about the perimeter? We don't have a formula for that because all you have to do is add up all the exterior sides. So starting here, going clockwise, 8 meters plus this side, which I know is 13 meters, plus this slanted side, which is 8 meters, plus this base down here, 13 meters. 42 meters. Not square meters, right? Perimeter is just measuring a length, not an area. So 42 meters. So note that finding area, slant lines do not get involved. Finding perimeter, they do get involved. And that interior side does not get involved. You don't see any 6s here because the interior side does not count for perimeter. Let's just find the area of this triangle. Got some triangle like this. Right angle there showing that this is 12 meters and this is 31 meters. Okay, area for a triangle is 1/2 base times height. Hopefully there's no confusion about what numbers to use. I mean, there's only two numbers here, so you don't have much option, right? So 1/2 times base is 31, times height is 12. Okay, so I can just pop that into the calculator, 31 times 12. And then divide that by 2, because multiplying by 1/2 is the same as dividing by 2. So I'm getting 186 meters squared. Now let's say, following along in example 6 from the text, a farmer is wishing to fertilize this triangular plot of land. Why does he have a triangular plot of land? Who knows? But he does, and he's trying to fertilize it. And a bag of fertilizer covers 15 square meters. How many bags will he need? How many bags are needed? Or she, right? It could be a girl farmer. Anyways, that's not the point. Okay, so how do we figure out how many bags are needed? How many bags of fertilizer if one bag covers 15 meters squared? And we have 186 meters squared to cover. We divide, right? We divide that total, 186 meters squared, by 15 meters squared. That'll give us the number of bags needed. $12.4 bags. So he'll probably need to buy 13, right? He'll have a little bit extra, but he'll need to buy 13 because they're probably not going to let him buy just a quarter, or not a quarter, 4/10 of a bag there. Now, if he's got enough, if he needs enough, then he might be better off not buying bags, but by going to like a, somewhere where they can give you bulk fertilizer, not bags, right? Anyways, so what else can I say about this? Yeah, that's good. That's good. Okay. Okay. Oh, there was something else I wanted to say about this one. Oh, yes. In America, if you buy fertilizer, it's probably going to be measured in feet squared. So whenever you do your measurements at home to measure your plot of land, you would want to get the measurements in feet, just so you know, like if you ever do this stuff in real life, if you're buying things here in America, they're going to be measured in square feet or square inches, American units, not the metric units. Okay, example 6. Of course, anyone who's used the metric system, you know that it's superior, but we're not getting into that in this class. Find the area of the trapezoid. That's my little height there, 17 feet. This is 9 feet, and this is 12 feet. And I want the area of the trapezoid. I'll go ahead and write down that formula. A is equal to base 1 plus base 2 divided by 2. That's the average of the two bases, and then times the height. All right, I see a dashed line here, but no measurement on it. But that's okay because I know my height from over here. That's my height. 9 feet is my height. Maybe I can write that down. Base 1 well, it doesn't really matter which one I call 1 or 2. I'll call 12 the base 1. So B sub 1 is 12. B sub 2, so base 2 is 17. That's all the way across here. And I'm going to plug that into my formula. So 12 plus 17 all over 2 times 9. I'll say times 9 there. Order of operations tells me to do this first, right? So 12 plus 17. That's okay. I'm going to get a fraction. That's all right. 12 plus 17 is 29. Still over 2, then times 9. 29 divided by 2, just pop that into the calculator, you're getting 14.5. Some fractional amount, that's all right, and then multiply it by 9. There it is. And what are the units? They're feet, so this is feet squared. So the measurements are in, oh yeah, here they are, measured in feet. So the area is measured in feet squared. Could you find the perimeter of this? Oh, here we go. Could you find the perimeter of it? Yes, let's do that as a bonus real quick. When I say bonus, I mean like just an extra. So I'm going to redraw it over here. Whoops, where's my purple marker? I'm going to redraw it real quick. And yeah, let me say, when I say bonus, I don't mean it's going to be like a bonus problem on the exam or anything. I just mean like I'm giving you extra that the book is not doing. And of course I would do that because our book is kind of not the best sometimes. Okay, how to find the perimeter? How could I find the perimeter? Well, the problem is this side, right? The perimeter is supposed to be sum of exterior sides, so I can do 17 plus 9 plus 12 plus blank, right? What is that? What is that? What is that? That's the problem. But note that I can pull out a right triangle. That little right triangle in the corner there with this length being 9 feet, but I'm dropping the units just for a moment. And it's a right triangle, by the way, right? It's a right triangle. And how long is this side? Well, all the way across here is 17, and this part here is 12. All the way across is 17, and this part is 12, so this side must be 5. I can use the Pythagorean theorem, in case you've forgotten that. That is, if you've got two legs and a hypotenuse of a right triangle, they're related by a squared plus b squared equals c squared. So I can solve for the missing hypotenuse here, which is that diagonal side that I want. 9 squared plus 5 squared should be equal to c squared. That's going to be 81 plus 25 is equal to c squared. That's going to be 106 is equal to c squared. Just taking that sum. And now I run into a problem where I'm like, well, what the heck do I do here? Because I know I take a square root on both sides to cancel out the square on the c. So I'm getting square root of 106 should be equal to c. But what the heck is that? Well, just ask the calculator. Just go ask it to do square root of 106 and just round. So I'll say c is approximately, and I'm getting 10.3. 10.3, because it's 10.29, so I'm just going to round to 10.3. Okay. So that means this side here is 10.3. Feet, still feet, right? Still feet. Which is not a nice whole number, but it's still manageable. So my perimeter then would be 9 plus 12 plus 10.3 plus 17. I messed up. 9 plus 12 plus 10.3 plus 17. 48.3 feet. Probably would not ask you one like this on the test or even in the homework. It's a bit too much to ask, probably. But there it is. If you needed to do it in real life, that's how you could do it. Actually, really, to be honest, in real life, how would you do it? You would just, like, if this was a floor plan or something, you would just go measure that, right? You would actually go like measure this. You wouldn't plop down some math on paper to do it. But if you needed to, there it is. Let's talk about circles. So circles. You got a circle with radius r. The distance around the edge of the circle is called circumference. Let's just say the distance around the circle. Here's the way I like to describe it, and a lot of students seem to really like this description of it. Imagine you take a tire or some wheel, like it's easy to imagine like a bicycle tire, and you have a bicycle tire, and let's say you dip it in paint, like some red paint, so it's all, it's covered in red paint. Okay. And then you stick a nail in it. You stick a nail in the, what color is the nail going to be? Doesn't matter. Orange. Right at the top, straight up and down, there's a nail. Okay. And then you roll it along. Okay. You roll it. Whoops. No. Roll it. Okay. Until it rolls all the way back around with that nail pointing right back up again. And that paint mark there, the length of that paint is going to be the circumference of the circle. So you roll it until the nail is back up top. So one full revolution, and that length of the mark you left on the ground, that would be how long the circle, a circle's circumference would be. That's one way to imagine what circumference is. If you like, or here's a maybe even easier thing I just thought of. Take the bicycle tire and cut it and lay it flat. That would also be circumference. Okay. Circumference, denoted by C, is equal to 2 pi times the radius. So you got to know radius to find circumference, or diameter. But if you have diameter, you can find radius, because we talked about that relationship in part 1 of this section. I'll write it down again. So diameter is equal to 2r. So with some diameter, maybe like this. Okay. The area of our circle, so if I've got some circle, a radius r, the area is going to be pi r squared. What is area measuring? Remember, it's the like as if you were to paint it, how much paint would you need? So circumference is the distance around the outside of the circle, while area is like how much space how much it would take to cover the circle. The number of square units that are needed to cover the circle. Example 7. Find the circumference and area of a circle with radius 15 centimeters. Not a question, it's a statement. Sorry. All right, so it's my circle. Man, that's pretty good. Okay. 15 centimeters. Here's my radius, 15 centimeters. I want the circumference and area. I'm going to show you two different ways to do this here. Two different ways to go about this. You can use 3.14 as an approximation for pi, and that's going to be the first way I do it. So this is going to be, in orange, is going to be approximations. And then I'll show you how to leave it as an exact answer in terms of pi as well. All right, so first of all, a is equal to pi r squared. That's area, finding area first. So now I'm going to say that's approximately, I'm going to use 3.14 for pi. Oh, pi is a crazy weird number that you will learn is always involved in any kind of calculation you're doing with curves, curved shapes or arc lengths, or it comes up all sorts of different places too that you wouldn't expect it to. But it is a decimal number. It's an irrational number that never repeats and never terminates. We could talk about pi for an entire course, but all we need to know here is that you can approximate pi by using 3.14. If you ask your calculator what pi is, depending on your calculator, you can get even more digits. But the point is it has infinitely many digits. This little Greek letter pi, that's what it is, it's a Greek letter, pi, holds infinitely many digits in it. Okay, this little symbol holds infinitely many digits. When we want to write it as a number, we have to approximate it. When your calculator uses it, it approximates it. It gets a better approximation than just 3.14. Like my calculator saves like 20 digits of it, but it's still eventually an approximation. The only way to get the full power of pi is to leave it as a little Greek letter symbol. And I'm going to talk about, I'm going to solve it that way as well. But let's keep going with this approximation route. So I'll say 15 squared here. That's r squared. So when I calculate this now, I'm getting 15 times 15 is 225. And then I'll do times 3.14, and I'm getting 706.5 centimeters squared. So the area approximately, a very good approximation, but still an approximation for this circle with radius 15 centimeters is that 706.5 square centimeters. My circumference is 2 pi r, again involving pi. So if I approximate pi by 3.14, notice when I introduce the approximation, I'm using the little squiggly equal sign. And then I'm going to say r is 15. And now I'm just going to multiply those. 2 times 3.14 times 15. And I'm getting, then I will say, sorry, 1 second. Sorry about that, cat interrupting. Okay, so just taking the product of these three in the calculator, I'm getting 94.2 centimeters. So circumference is like, you can think of it like the perimeter in that it measures only single dimensional units, not square units like area does. Now, what if you wanted exact answers? The way you would describe this is you are leaving answers in terms of pi. That means leave that little symbol in there, leaving answers in terms of pi. A would be equal to pi r squared, of course, still the same formula, equal to pi times 15 squared. Notice here I'm leaving the symbol pi in. I'm not approximating. and 15 squared is 225. So I would flip that around and write it as 225 pi. That's 225 pi, leaving my answer in terms of pi there. So that's as far as I go. That's an exact answer. Leaving it all the little digits stuffed into that little letter pi. My circumference, 2 pi r, whoops, 2 pi r is 2 pi times the radius, 15. I know that 2 times 15, I can multiply those together to get 30 pi, leaving that pi at the back, kind of like a variable, like a x almost, right? But it's just a little Greek letter that has infinitely many digits stuffed inside of it. So if you want to leave an exact answer, this is how you leave it. Oh, and it's still measured, sorry, it's still measured. This is area still measured in centimeters squared. This is still measured in centimeters. Now, in real life, these approximations are probably a bit more useful. Like if you're trying to paint some circle, for whatever reason, you're trying to paint a circle with radius 15 centimeters, like some disc or something, and you go to the store and you tell the Lowe's employee, you go to Lowe's and you say, I need 225 pi square centimeters of paint. They're going to be like, what did you just say, right? But if you say this makes a lot more sense, right? I need about 700 square centimeters of paint. They'd probably still look at you like you're crazy because, you know, again, in America, we don't deal with centimeters. We deal with like inches or feet, right? But this is a lot more meaningful in a real life situation than this. But if you go on in math class, this is a more appropriate answer most of the time. Okay. Let me glance through the problems I gave. 9, 8, and 17. Yeah, number 8, you're going to need the Pythagorean theorem, which we went over as that, I did that for that parallelogram problem in example 6, I believe it was. Number 9, we did one of those, and 17 is a triangle. Cool. Yep. All right, that is it for section 6.2.